All right, what's up everybody? This is Ryan here, and I'm going to do some more work on my compiler today. I'm not going to ramble too much. I'll just show you the work I did off camera. If I can find my appropriate thing here. There we go. Oh, not what I wanted. Okay, so in yesterday's live coding session, we basically implemented function declarations which did not have parameters. I guess let me show you kind of what I mean by that. Let's go ahead and open this up. So yesterday what we did is we worked on functions that kind of look like this. And then we worked on functions which look like this. And this is, so the language here is called donk, which is my language. Sorry, one second. So this is donk language. What's up, Gen 2? So yeah, and then we worked on functions which have parameters. So it was something like a string, b, boolean, whatever. There's a third parameter. What's up, Nibir? No, this is C double. And as you can see, like I've been saying repeatedly, my language donk, it's largely inspired by the Kotlin programming language. It looks pretty similar. One key difference being we use the instruction keyword instead of function. I think function is something that makes more sense to mathematicians. I'm not a mathematician. So yeah, and then I actually did a bit of work off camera, not too much, but what I did off camera is I also implemented parsing of return types. And of course, all this was done in test-driven development. What's up, Yash? So that's what I worked on yesterday, and including the stuff I did off camera. And as I've mentioned before, everything I did here was backed by a test. So I wrote some kind of test with the input input source code that I wanted to test against, and then I wrote the code until the test passed. So once I figured out how to parse functions without parameters, I then wrote a test for functions with parameters and with returns and stuff like that. And let's just go ahead and run these tests to make sure they haven't suddenly broken overnight. What's up, Harish? And as you can see, we are all green on everything. So our language is capable of parsing val declarations, var declarations, and pretty much every kind of function declaration that I can make. So the thing I need to decide now is what to build next. And there's a lot of different options. I'm just going to open up the BNF. So as I mentioned yesterday, if you're ever going to do compiler development or language development, you're probably going to want to learn about Backus and hour form. Do you need to become an expert in it? Probably not. But yeah, so this is basically like a way of representing the language recursively. And as you can see here, we've covered function declarations, we've covered variable declarations, and we've covered value declarations. So basically what we're working on next is all different kinds of statements. We've already implemented a block statement. We kind of needed to do that, or we at least partially implemented a block statement. Let me just double check to see. I don't think we implemented it for every kind of situation. Let me just double check. Parse block. Okay, I think it actually probably would work. Okay, well that's cool. What should I do next? I think an easy one to work on would be a return statement. Relatively easy anyways. I don't think I'll get into while or for loops. I don't think I'm doing for loops in this language yet. I probably will do them eventually because they looked annoying. Yeah, I don't think I actually have for loops, so we can remove that. Yash asked, will it be dynamically typed or statically typed? Probably statically typed. Like at the moment, I have 3 primary types, just type string, type double, type boolean. So most likely it will be, at least for now, it'll be statically typed. I don't have classes though, and I don't plan to implement them. So we'll see. I'm not really sure exactly where I'm going to take this language, but I do like types. I'm very fond of type theory. So yeah, anyways, isn't that bizarre though? Types but no classes. Okay, I think I'm going to work on return statements. So I'm actually going to create a new test class. And we're going to call this one parser statement tests. And as you can see, I just copied it over from another one. I don't think I'll bother with this test data here. We will create... By the way, you're probably going to hear some construction noises. I apologize about that. They're renovating the apartment I'm living in, which seems to happen every time I move to a new apartment. People are renovating it, which is really friggin' annoying, but whatever. When will the next Android Q&A be? That's going to be on Sunday at around the same time. For me, anyways. Okay. So let's just get started with a return statement. So I might as well teach a little bit while I'm here. So how you prepare a test is you set up the test arguments, you figure out the expected result, you test the unit, and then you assert the results basically. And that's just a off the top of my head general approach here. So the first thing we need to do is we're figuring out what are we going to feed into the parser. What do we need to feed into the parser in order for it to test properly? So I think what I'll do is, since a return statement is only going to show up in the in a function declaration, I'm going to copy the function declaration here, which has the return type listed. I'm probably actually just going to copy this whole function here because I can pretty much use all of it. And then we'll just make some minor changes. So one of the things is we'll need to add a return statement. So how we're going to do that is we're going to say, we're just going to copy a token. Return. And that's basically it. We don't really care about white space because this isn't Python. I don't think Python's a bad language, but one thing that really pisses me off about Python is I do not like the how I prefer brackets over worrying about white space. I'm sure if I was raised on Python, I would probably say the opposite though. Okay. So that's basically it. We set up the test arguments, which was really easy because it's very similar to a test we already have. We figure out the expected result. So the only difference here would be for the function expression, it should have a return statement, I guess. Let's just go to base expression. Actually, base statement. So it has a keyword and a value, which can be an expression, which makes sense. Okay. I'm just trying to think of how we're actually going to parse this. So the keyword would be return, of course, and I'm not even sure why we would need that, but we'll just roll with that for now. So it should be a return statement is what we return here. Expression statement, we don't actually need to do an expression statement here. We do a return. I'm just going to get rid of this for now. So we say return statement. We give it the keyword. I don't think we actually need that keyword because it's a return statement. So why do we need that? So I'm going to ask, why is there always a delay of 10 seconds after I type to reach your screen? Let's see. That is the, oh, it's because I'm on normal latency. So I'll have to actually fix that. I didn't realize it was on normal latency. I shouldn't require normal latency since the internet has been pretty stable at my new place. All right. So for the return statement, we just have a token that says return, so that's not very interesting. Am I in the wrong test again? I'm in the wrong test. I do this a lot. I apologize. Okay, we're just going to fix that up. Statement tests. This is where we want to be. So this is going to be a return statement. This is not going to be a literal expression. This is going to be return. We don't need the literal there. Okay, cool. And then we need just a base expression here. Or the expression would be, I think it's a literal, yeah, it's a literal expression. And so that's going to be donk token. I should just copy it. That's probably a better idea. Okay, so we've got the return statement, then we've got our literal expression, and we've got the return keyword, so that should be fine. I think that's all we need to do in terms of setting up the test. So here we're setting up the expected result, what we want to see happen. And that looks proper. We don't have any arguments, right? No arguments. This should not be called parse binary expression. This should be parse return statement. So yeah, we set up the test arguments. We figured out the expected result. Now we're going to run the test. The test is obviously going to fail because we haven't implemented it, but that's just going to help us make sure that the test itself is well formed. All right, assertion failed. That's exactly what we want to see. So by assertion failed, basically we're typing this assert keyword here, and then we're comparing the expected result against the actual result. Obviously it's going to fail because we haven't implemented yet. So now we're going to work on implementing it. So let's see here. Where is our handwritten parser? Going to clean things up a little bit here. Okay, so here we have our handwritten recursive descent parser. So we're going to end up getting into parse block. So a block is like basically this thing here, a code block. And then we're going to get into, we're actually just going to call, I think, parse declaration, because declarations could be there. Excuse me. And then we're parsing a return statement and a literal expression. So we're going to end up in parse statement, and then this is where we need to sort that out. All right, so when tokens current dot type is literal string, we create a literal expression. Then we're going to make a branch for token type dot return. It's almost like the IDE knew that. And then we're going to call a function. So we're going to say val parse return equals parse return statement. We'll call it that. We will pass in index. Do we have an index here? No, we do not. So this function was actually written before I changed the way I was actually writing this recursive descent parser. So I'm just going to refactor it a tiny bit here. So we're going to say index equals current. And within the rest of the function, we're going to use index. So if, let's see, index plus 1. Pair. This doesn't actually make a lot of sense here because we're not actually returning anything. So I don't see how that would work. Swamanath asks, is token type a sealed class or an enum? So it is an enum class. So I teach this a lot in Kotlin. Generally speaking, the way I would think about enums and classes, or sorry, enums and sealed classes in Kotlin is, so sealed classes are used to represent a set of restricted types, whereas enums are a set of restricted values. Now, obviously the definitions get a little bit muddy because you can have your sealed class's children hold on to values, but generally speaking, if you only need to represent a set of restricted values or things, then you would use an enum, is generally how it works. So you've got it right there. It's basically saying we want to define these very specific things and use them in situations where we don't want to just be like matching against a bunch of strings or something. So yeah, token type, it's just this giant thing. I talked about this in the previous live stream, but basically how the front end of a compiler works is you have a tokenizer, also known as a lexer, also known as a scanner. And so you basically you give that thing source code. So source code would be exactly what you see here. The tokenizer will produce a list of tokens, in this case donk tokens, and then that gets fed into the parser, which is what we're writing now. And then the parser produces this thing called an abstract syntax tree, which I won't ramble about because I'll ramble about it later. The abstract syntax tree is effectively, though, these two types you see here. We have base statement and base expression, and these things represent the parts of the language that actually have meaning, essentially. So here we're in the parser, and it's basically looking through the list of tokens that was generated by the scanner, and then we're trying to make sense of these tokens, essentially. Okay. So I was just confused for a second here. So we say when token type literal string is, I'm wondering if we even actually use this thing. Yeah. We didn't actually use... Okay, so this is old code. Yeah, this is old code. I was looking at this and saying, well, it doesn't have a return statement, so it's not actually going to do anything useful. But how come my tests are still passing? The reason why the tests are still passing is because the useful code is in parse expression. The reason why it's messed up is I first tried to write a recursive descent parser from the bottom up. That turned out to be a terrible idea. So that's why there's some old code which is apparently pretty bad. So we should only be looking for statements here, and literals are expressions, not statements. So what we would do, let's just get rid of this whole block because it's completely useless. Hey, what's up, Omar? Marhaban. Sorry, I've been meaning to phone you back, buddy. That's been busy. Okay, so parse return. Right, so we're going to parse a return statement. We pass in index. We can probably pass in index plus 1. We can just check what the next token is. Or should I do index plus plus? Let's do index plus plus, and then we'll pass just index in. And then we'll create our parse return statement function. So this thing's going to get index, and then it's also going to get the whole list of tokens. Sorry, I'm not picking my nose, I'm just scratching it. My girlfriend and I have cats, and even though I grew up with cats, I think I might now be mildly allergic to them. Okay, cool. So we got that. This is going to return a pair, which is a Kotlin type where you can return multiple different values. And it's going to be a pair with base statement and the new index. Okay. And so what we're going to do is when we have a return statement, basically it looks like this. So we say we have a return keyword or a return token. And then after that, we have just an expression. And then I think, I'm trying to remember, do I worry about the semicolon or do I let the expression itself worry about the semicolon? I think we'll have to adjust this later. At the moment, the expression, the parse expression function worries about whether there's a semicolon or not. I think I might have to change that because I think there would be situations where an expression doesn't actually have to be followed by a semicolon. So what I'm thinking is a situation where we have like val a double equals sum 1, 2 plus sum 1, 2, whatever, doesn't matter. But this expression wouldn't actually be followed by a semicolon, and it would still be syntactically or semantically correct. So let's just add a to-do here. Okay, good enough. So just for the time being, we're just going to worry about implementing this particular unit. So return I almost feel like I should fix this semicolon thing now. Yeah. So we're going to switch gears a little bit. I'm just going to return some kind of dummy data here, and we're going to figure this problem out first. The reason why I want to figure this out is that ultimately, just knowing this situation where we're not necessarily going to have an expression always followed by a semicolon, I kind of want to fix that because I think it's just important to fix that. I think it also affects the return statement quite substantially. Oh yeah, unfortunately, Swamanath, I can't change the latency while I'm streaming, so the delay will be there until next stream. You could write expression should be followed by either an algebraic operator or a semicolon. Yep, that's correct. The thing is, though, that's true. It's just I'm not actually sure that I want this parse expression function responsible for checking the semicolon at all. I don't think I do. Yeah, I don't think I do. So what I'm going to do, I'm going to actually just delete this. Or I'm going to copy it, because I might still want this thing. I'm going to rerun my other tests to see which ones are broken now, which might be all of them. And then we can see. Oh, nothing's broken. That actually really surprises me. I guess they probably just skipped over the return expression. My tests passed, and I don't know why. Oh, wait a minute. Oh, yeah, okay. Hold on. Parser declaration tests. So these ones all passed. That genuinely surprises me. Okay, now I need to figure out why they passed. I guess it's because we're probably just like skipping over the semicolon. That would be my guess. But I'm not 100% sure. Okay, whatever. So the parse block is responsible for looking at statements, the statements that we're paying attention to right now. So it's going to parse an expression statement. All right, I need to understand why the code still works, because that's kind of weird. So we're just going to throw some breakpoints in. Okay. Okay, so we parse our literal expression. That's fine. We increment the index. Then we get to this pair. So index is at 6. The tokens, so 6 would be the semicolon. We return the index of the semicolon to parse block statement. Yeah. Okay. So the index is now pointing to the semicolon. All right. Then we go back up to parse this thingy. We come back up to so many functions. Parsers are complicated. We come back up to parse function declaration, and the index is pointing at the semicolon. Yeah, so we're pointing at the semicolon now. We return the pair, and we increment by 1. And now it's pointing at the bracket. Sorry, I just need to run through this in my head. And then we go back into parse declaration. We don't find anything. We go into parse statement. We don't find anything. Parse statement. And we go into parse expression. It's weird. It should be throwing an error, so I'm still confused. That's really weird. It comes back in here. Index is 7. Something seems wrong here. Something seems terribly wrong. What's up, Gentavia? Thank you. Why don't we have the closing brace? Parser declaration test. I don't know. Okay, well, I think I'm just going to stop worrying about this for now. Yeah, we're just going to work on the this unit because I honestly can't figure out why the test is passing, which is kind of the whole point of having the tests. So let's just carry on implementing things. I am happy that I removed that, though. I think that was the right decision. Okay. Excuse me. Okay, so parse return. So we expect a return statement. I think we already matched for that though, so we skip over that. Maybe let's not skip over that. Let's, no, I kind of need to do that. Yeah, okay, we skip over that. So we're just gonna type here, assume return has been matched. Swaminoth asks, is it necessary to write throws if your function throws an exception? This is actually a very critically important thing to understand. So depending on what I'm doing, but in Kotlin in particular, I don't really use try catch unless I have to. Sometimes if you're using some kind of library, you necessarily need try catch. I try to avoid it, and instead I use basically constructs like a sealed class and then my own exceptions, and I don't throw them. I avoid try catch, and when you kind of need to make your decision. Either you're going to use try catch as your primary means of representing exception cases, or you can write your own way of representing those things. And by sort of giving yourself the control of managing your errors, I find it makes your code a lot easier to work with, a lot more easier to read as well. So the answer to your question directly is no, well, technically yes, if your function throws an exception, I think you'd need to write, I'm not sure if Kotlin forces you to write throws, but what you can do is you can just use your own code, your own classes and stuff like that to actually represent those exceptions, and then just completely avoid having to use throws, try catch, etc., which is what I typically recommend. And I think that's actually what Kotlin overall recommends you do. I remember reading something in the documentation about how they don't really like those sorts of exceptions. Okay, so we go to parse return statement. We assume the return has been matched, so then we need to parse an expression. So we would say val parse expr equals parse expression. Now, again, I'm thinking, what if we have multiple... I think what we need to do is, I think we need a loop here, actually. Because again, my brain's going back to this situation. That would actually be a binary expression. Okay, you know what? That's covered by a binary expression. So let's not actually, we'll implement that when we implement binary expressions. This is an important thing in test-driven development. Hey, what's up, Ashish? Don't worry about things you're not implementing yet. Just worry about getting the code to work with the things you're, the specific issues, and don't worry about complicating things. So we're dealing with a function that just has a string literal, so we're going to just worry about that specifically. So we say val parse expression equals parse expression. This is just a convention I'm using. Var index equals current. We don't really work on the current that gets passed in. We work on this index thing, which starts out as current. Current will be the token after the return statement, which is what I want. So we say parse expression index tokens. So it's going to parse an expression. Oh, thank you, JP. I really appreciate that, man. I don't know if I've surpassed many people, but I've definitely branched out into a lot more than just Android development. But thank you so much. I really appreciate that. It's very kind of you. Yeah, you're very welcome, fellow. I'm glad it helped. Did anyone see the giant argument I got into? Someone commented saying that one of the questions I had in the mock Android interview was misleading or something like that, and this person I got into this like giant technical argument in YouTube comments. It was pretty funny. But the irony is that the question he was saying was like a dumb question was actually a question I'd been asked in a Facebook interview. So it's like, I think it's probably important for me to share that one with people trying to learn Android or prepare for interviews. Okay, val parse expression. So we call this thing here and that's going to return a pair. And then what we do is we say, does it return an expression? No, it returns a base statement. So we say if parse expression dot first is error expression. So just to do with this whole idea of not using try catch, I had to have these expressions and the statements be capable of representing errors. So I needed to add subclasses of base expression and base statement, which basically had that capability. So there's trade-offs to not using try catch. It sort of forces you to have to handle things yourself. JP Ventura asks, are you creating the language compiler from scratch or using Kotlin native infrastructure? It's going to be from scratch. Let's see here. I plan to compile to WebAssembly for this language. So what I might do, I know Kotlin has a WebAssembly compiler, so I might look at that, and if whatever part of it is open source, see if I can use some of that code, only if it's open source, obviously, but we'll see. But I'm also creating a language alongside the compiler. So this will be written in Donk language, which looks kind of like this. At the moment, it looks quite a bit like Kotlin. Some differences. Okay, if parse expression.first is error expression, so basically that means if it's an error, why is it complaining? Oh, it should be error statement, that's why. I can't type statement apparently. Okay. Then we return get error, or I think we just return, we can just return pair parse expression.first. We basically just pass that error up. And then we would return parse expression.second, and I think we need to increment it by 1. Yeah, we would need to increment it. Also, that should be indexed down here. Where am I? Parse return statement, where is it? Here we go. Sorry, I got lost for a second. So I think we would do +1 there. Okay, so otherwise it should be an expression. So we would say, or actually it would be a statement. So else the next thing we would do is we would check for a semicolon now. So we're going to say if match types else index plus plus. No, that's not what we do. Else index equals parse expression dot second plus 1. And then we also need to, we're going to say var expression statement, I guess, expression statement. I think I'm confusing myself. So let's look at the return statement itself. It accepts a base expression. Parse expression returns a base statement, though. Okay. What's up, Sergio? So I have two choices. I can either have my parse expression function return a base expression, Or I can have it return a base statement, which returns a expression statement. If that annoys you that there is a base statement and a base expression, and then there's also a base expression, an expression statement, that annoys me too, but that's apparently how languages work. But what I'm saying is I can either have it return an expression statement and then I just cast it to expression statement. And then I grab the expression from it. Or I change the function's signature so that it returns a base expression. The thing is, though, in either case, I will have to cast it, and I think leaving it as a basic statement right now actually makes some things easier. So for the time being, we're going to cast it. So basically what that means is expression actually we want to do that, and that'll be a val. So we're going to say expr equals parse expression dot first as expression statement dot expression. Okay, so we grab up our expression, and then we match. We want to look for the semicolon now. So we say match types tokens index token type dot semicolon. If that, then we're going to return return statement. Yeah, return statement. We give it the keyword. Why do we need that? I don't see why a return statement needs to hold on to the return keyword, because it's a return statement. I don't see any utility in holding on to the return token. Okay, well, I'm going to make a bold move here. We're just going to get rid of the return statement keyword thing, because I don't think we need it. And then here we're just going to return expr. And this needs to be a pair. Sergio asks, why are you creating a programming language? It's kind of been my goal as a self-taught developer to pretty much learn every sort of field, every area of programming. Because one of the things that I felt like I was really missing by not going to school was a lot of computer science concepts and things like that. Now, with that being said, I think unless you go to a really good school, they don't really teach you much anyways. But yeah, I just would love to I want to understand computers at every level. So, like for example, I built a computer in Minecraft to understand digital circuits. I learned about operating systems. I'm trying to cover everything. I want to get into machine learning soon as well, but I have too many things to worry about right now. JP says, how will you understand a recursion finishes without a return token? If I understand your question correctly, I'll understand it by returning the new index. Every time we call a function, it returns an index, which is essentially like the new location to start looking in the in the list of tokens that we have. So I think that answers your question, but if not, let me know. Okay, so we have a return statement. Now I'm just wondering, do I need to increment? I do need to increment index here. Yeah, because we want to, oh wait, no, hold on a minute. Hold on a minute. I made a rule. What is my rule? Caller increments by 1, not callee. So we're not going to do that. I had to make that rule because I kept mixing up whether the callee or the caller moves to the next token in the list. And so, yeah. And then, of course, we need an error pair. Otherwise, so the message here will be expected semicolon at index, but instead got tokens index dot type. Okay, and then we return index. Okay, so I think I've written enough code that I can run the test. I'd be pretty damn surprised if it passed. Oh, maybe I didn't finish this off. No, I didn't finish off parse statement. Okay, so here we're going to say if parse return dot first is error statement, then we return our get error pair. Or no, I think we just return a pair with can we just return first? Why can't we do that? Oh, no, not first, just parse return. We just return the error up the chain. KMM compiler for Python. That's cool. I will eventually get back to you, JP. I've written a little bit of Python, but not a lot. Okay, so I think we can just return an error statement, but the reason why we wouldn't want to do that is if I need to increment the index. Here I am like thinking about breaking my rule. Right. I just need to make one change here, just ergonomically speaking. We're going to move, where is parse? All right, so we're going to move parse statement just to below parse declaration. I think I am going to increment the how can we do this? We can say return pair. Again, it's just that issue of making sure that I'm returning the appropriate indexes. Parse return dot first and then parse return dot second plus 1, I think is what we're going to do. Okay, now what do we do if otherwise? We have successfully parsed a return statement, so we would return that return statement. So we would say return else return pair. I think we can really just say parse. No, it's the same issue, isn't it? Yeah, it's the same issue. Now, this is completely repetitious code, so I think I can actually just... Yeah, why don't I just do that? All right, we're experimenting a little bit here. Okay, I'm going to run the test now. Okay. Okay, so we're getting assertion failed. So the first thing we're going to do is see where it is failing. So I'm just going to throw in a couple of breakpoints. And we'll look at the errors. So just, I can't remember who it was asking about the, I think it was Swaminath, sorry if I mess your name up, was asking about exceptions and stuff like that. By handling exceptions the way I do, I don't have to worry about reading stack traces and stuff like this. I can actually just use these breakpoints and then look at exactly the errors that are being returned by the parser. And all of the errors were written and explained by me, so they're really easy to understand. So I'm just going to see, we're going to look at result here. We see one exception, and it says expected a semicolon at 10, but got a right brace. So probably that's going to be in the return. Parse return statement, probably right here. So we expected a semicolon, but we got a right brace. So what that basically means is we wouldn't increment the index. That looks like an endless loop, so that evidently wasn't the solution. Okay. So what we can do is let's again take a look at parse expression and see what it's doing to the index. So I think I see what the issue is. It's breaking my rule. It's not supposed to be incrementing the index. Let's try it now. Infinite loop looks like. Okay. So parse expression +1, +1. So I think it's parse block that's having this issue. Parse result second +1. Let's try that. Okay, that didn't fix. So it's infinite looping somewhere, so I need to figure out where it is infinite looping. But it's important, don't make like 5 different changes before. So the only loop I'm aware of is in parse block. It's got a while loop. And I think this is probably where it's looping. Let's see what's going on. Okay, I definitely hit debugger. Okay, so current isn't being incremented, or index isn't being incremented. So what are we doing? We're going parse result. We're calling parse declaration. We're saying parse result, so it's a return statement. Okay, we're parsing the return statement in the parse block. And then it's a return statement. Oh, I think I know what's going on. I don't think okay, I think I've got it. This one's looking for an expression statement. So it's not finding, okay, I get it now. Okay, so I need to add a matcher for the return statement. That's the issue. I might still need to tweak the indexes a little bit, but I think this is the main issue. And this is why being really good with the stepper tool is, in my opinion, a very useful skill, at least for this kind of coding. Okay. So we add the return statement. We say index equals parse result dot second. I feel like we still probably need to increment. No, let's just see what happens when I run it now. Okay, progress. We don't have an infinite loop anymore. Let's debug it now. And what is the error now? Expected expression, but received a right brace. Okay, so we called parse expression. And we received a right brace, which would have been the very last character in the list of tokens. So that kind of tells me that we're calling parse expression when we should be done calling parse expression. So how do we skip over this thing then? That's what I'm wondering. I feel like we must have skipped over when we check for the right brace somehow. Noob Master asks, will you launch it worldwide? If yes, when? Well, will it be like publicly available? Yes. When? I wouldn't really, it's not really a real language until it's compilable or interpretable or transpilable to another language. I'm planning to compile to WebAssembly. So when I write the part of the compiler which compiles to WebAssembly, I'm not sure. I might end up using LLVM for that, at least to help, but we'll see. Okay, index is 8, so we're... Yeah. Now index is 10. Which is the right brace. Yeah, okay. So index is now 10. So it shouldn't be here. It shouldn't have jumped into parse expression again. So why did it do that? We returned I don't really understand that. It should have returned from this function return pair, block statement, statements, index, yeah. It's like it jumped back into parse result. This is going to take some serious debugging. Okay, tokens index 10 is a right brace. It goes into block statement. It returns this thing. And then we end up in parse statement. Okay, so we called parse block again? Why did we call parse block again? I'm pretty sure this is some kind of issue with indexes. Oh no, it just returned from parse block. Never mind. Okay. All right, let me just debug one more time. Okay, first iteration of the loop, index is 7. So we parse the declaration. The first thing we get is the, should be the expression statement. What the heck's going on now? Sorry, my debugger seems to be a little bit wonky. Why doesn't, I don't understand why it's not letting me jump to breakpoints. That's really weird. Okay, returns the expression statement. We call parse expression within parse return statement. That makes sense. We give it index 8. Hey, what's up, Ravi? We give it index 8, which is the literal string. Oh, okay, I think I know what's going on. That should not be... Oh. I think I know what's going on. Okay, let's go back to our loop and parse block. Okay, so I think I'm calling parse expression too many times. So the return statement index equals parse expression second. Yeah, it's quite a mouthful, eh, Ravi? You can probably tell I'm Canadian by my usage of the phrase "a." So basically what I'm thinking here is that it's... let me just make sure that we're actually calling expression statement. I think what's happening is we're parsing an expression twice is really what I'm trying to say here. Oh. Oh, wait a minute, wait a minute, wait a minute. Wait a minute. Wait a minute, wait a minute, wait a minute. Okay, I think I got it. We'll see. Oh, I got it. Okay. Okay. It was just, I knew it had something to do with the indexes. All right, we got a green light. Good. I was supposed to be incrementing this in following my rule of having the caller move the thing over, so cool. All right. Oh, that was slightly annoying. So regarding this thing, I might as well ramble about this. So recursive descent parser. So the easiest part is to explain a parser. So a parser, in the most straightforward, I should say, way of explaining it, a parser, if you look at the whole chain, we start with source code, which is, for example, this is some source code. We feed that source code, which is just a string, into a tokenizer, also known as a lexer or a scanner, and that thing produces a list of tokens. And then, holy crap, thank you, Vlad. I appreciate that. So the tokenized input is basically like we look at individual tokens here. So this is like instruction keyword. This is an identifier. This is left parenthesis. This is right parenthesis, left bracket, blah, blah, blah. The parser looks at those tokens and attempts to basically build meaningful elements of a language. So language elements that have meaning. The tokenizer doesn't care about the meaning. It just looks at individual things and turns them into a token. Whereas the parser looks at larger portions of the language and tries to say, is this thing here, for example, a val declaration? And then it'll look at multiple different tokens to assert that. The recursion part is that, as you can see here, we start by calling parse declaration, which is like a top level thing. So a declaration would be, for example, this is a function declaration or an instruction declaration. Oops, wrong way. So we call a parse declaration, and then basically it will, if it doesn't find a declaration that it's looking for, it will call parse statement. And if it doesn't call a, if it doesn't find a parse statement, it will call parse expression. And then these various functions that we have, they can kind of recursively call, they have to recursively call things. It's hard to explain recursion. So kind of how it works is it works its way, it creates like a sort of a tree-like structure out of the tokens, and then it'll work its way into something like this, and then it'll work its way back out and spit out this whole thing. So this whole thing here is a function declaration, and then it'll look for the, the parameter list next, and I'm doing a terrible job of explaining this. Eventually I'll actually make some lessons explaining this stuff, but basically, unfinished buggy code? Oh, there's a question here. Thank you, Vlad. I really appreciate that, man. Okay. Ravi says, I just read a piece on how management is pressuring engineers to push unfinished code. It's great. Can I paste the link here? Yeah, I don't mind as long as it's a legitimate website. I'm not surprised, though. Sounds like terrible managers. Okay, so I got the test that I wanted passing. Now I'm going to rerun the other tests because I made so many different changes, and we'll see if those are still passing. Yeah, everything's passing, much to my surprise. Cool. All right, we have implemented parsing of return statements. By the way, I don't know if anyone's actually learning about parsing, but the way that I was finally able to figure out, how a recursive descent parser works is you basically want to just think of it as having two kinds of functions. You've got parse functions, which look at large portions of source code. So for example, it would look at this thing to try and find parameter list. It would look at that whole thing to, oh, not what I wanted to do. Hey, hi mom. Oh, geez, I can't click on anything. It's basically made up of parse functions which attempt to look at one or more tokens and create some kind of part of a abstract syntax tree out of that. And then it has match functions, and the match functions just look at individual tokens and attempt to match them against various things. So that's really, if you can understand that really we're just trying to put a couple tokens together into some sentence essentially, and then we're using these match functions in order to just check on the tokens, it becomes a little bit easier to figure out what you're doing. But admittedly, it took me quite a while. Okay, let's figure out what we're going to do next. So I did return statements. What else do we have? I think I need to get into some more complicated stuff, like while statements, which is going to be interesting. The thing is, these functions can, you're right, Ravi, these functions can call themselves, like, what's an example here? Let's go to, okay, so we have this function parse block. So it parses a block statement. What is a block statement? A block statement is, and if you're watching here, it's one of these things. It's basically the, not those parentheses. It's two brackets and then whatever goes in between those brackets. It could be a lot larger than this, like it could be whatever. So it's looking at this whole thing. So if I kind of trace out how this works, we start by looking for a declaration, and we find the instruction keyword which indicates that we're looking at what is probably a function declaration. We jump into parsing of a function declaration, which requires finding the name of the function, the parameter list, an optional return type, etc. And then it looks at this block statement as well. It looks for the block of the function declaration. If we go into that block thingy, we see that it actually calls parse declaration again. So all of a sudden we're back up to parse declaration. So in a sense, it's hard to kind of visualize, but you, because we can have things like expressions and even declarations within other declarations, we end up with recursion. Hopefully that kind of makes sense. I haven't really figured out a simple way to explain it yet because it only recently started making sense to me. But that's kind of where the recursive part, and hopefully you can also sort of think of the descent as well. It's sort of, I don't know how to explain this other than if you rotate this thing by 90 degrees, it kind of descends through the code, but I don't think that'll help anyone. Okay, I've got some choices here. I can try and work on parsing while statements. I think that would actually be pretty easy because you've got the while statement, you've got the, the while keyword, you've got the condition, which is just an expression. And then you've got the body, which would be a block statement, probably. So, yeah. Why is that not a block statement? Hmm. Oh, one of my cats is scratching at my door. Cats are awful creatures. Horrible, horrible creatures. I think we only like them or take care of them because of Stockholm Syndrome. And if you don't know what Stockholm Syndrome is, you should look it up. Okay, we're going to work on... I'm just going to work on parsing while statements now. Because I feel like parsing if statements is going to be somewhat complicated, whereas I think I can probably do while statements. Let's set up a while statement. Okay, so we need our... So val test1 equals list of donk tokens. Now I think I'm going to put this within a function declaration actually, because I think that makes sense, because you won't have let's just copy this whole thing is basically what I'm saying. Yeah. Oh no! I hate my mouse wheel. It's annoying. It's too sensitive, so when I'm trying to like select and sort of scroll, it clicks by accident and then ruins my selection. Sam Light says most of the inbuilt assembly code has stacked to simulate the recursion process. All right. Kotlin actually has a tail recursion modifier, which is handy when it comes up. Okay, so we're going to set up a while. We're not going to care too much about what it looks like, but we're going to say while. And then I think I will have braces. So we'll do left brace. Oh no, we need to have the conditional. Or the condition, I should say. So this is going to be left paren. Let's go ahead and just add our right. Actually, we'll do it this way. Right paren. For now, let's make an infinite while loop. It's just going to say true. Because I don't... It just has to be... Sorry, you're going to hear some background noise from the construction. We're just going to make an infinite loop because I don't actually plan to like run this source code. It just has to be semantically correct. So we'll just do true in there. And then we have our... copy this block. And in this block, we're going to have the... Whoa, not what I wanted to do. We're going to have the braces. Left brace. Right brace. I'll probably just have an expression here. So that would be... Samlight asks, are you building the language for using in any product or a personal curiosity? Yeah, it's largely for educational purposes, both for myself and eventually the people I teach. Um, my primary goal with this language is to make something that is I could teach to kids, for example. Now, at the moment, it looks just a lot like Kotlin, and eventually I'll probably change the way it looks quite a bit. And eventually I plan to have it deploy to WebAssembly. So that's kind of the overarching goal with it. For use in products, I wouldn't say so. Educational products maybe, but not like, what's the word I'm looking for? Commercial products? I don't know how to explain it, but you probably understand what I mean. Okay. I think we're going to throw in... Can anyone tell me off the top of your head, does... Actually, I know the answer to that question. Never mind. Okay, so we have a while loop, which just contains an expression, which is just a literal expression. And it's an infinite loop. Let me just really make sure that the this list of tokens is well formed. So we have our while statement, or keyword. We have our left paren. We've got some kind of condition in there. We've got right paren, left brace, some kind of expression, right brace, right brace. Okay, I think that makes sense. Well, I'm not telling you. All right. And now I need to set up the expected result. So it's going to be while. No, that's not what it is. Sorry. While statement. And what does a while statement look like? A while statement has a condition, which is an expression. So it's got that literal expression. This is going to be true. Literal. Now I'm confusing myself. Type Boolean? I can't remember what my scanner... What does my scanner map that to? Boolean gets mapped to type Boolean. No, that's the type system. Never mind. Just the keyword. Okay, I get it. So this would be just false. Or no, true. Okay, cool. So this is the condition, and then we have the body, which is probably going to be I think it has to be a block statement. What else would it be? So why don't I just make it a block statement? I don't know, whatever. What I was talking about is maybe I should just make it a block statement here, but maybe, I don't know. I guess I'll just leave it more abstract than that. So this is going to be a block statement with, I think I have one of these somewhere. Yeah, I think this is it. Okay. All right. And that's all I need for a block statement, right? Yeah, just a list of statements. Okay, I think our test is ready to go. I don't think I'll bother with a return type. Oh. Yeah, I really shouldn't add a return type here because technically if either the block of the function as a whole or the while block doesn't have a return statement, then it wouldn't be semantically correct. So I'm just going to do a sneaky move and just remove the return type from it, because that's something we're going to worry about later. And then I also want to remove it from here. So we're going to say return type dot none. This isn't even really a concern of the parser. I think that's actually a concern of the compiler, but yeah. Okay, now we're going to run the test to make sure it's well formed. And it failed, but that's okay, it's supposed to. And now we go ahead and start implementing it. So while is a statement, so we're going to go to donk handwritten parser. We'll go to parse statement, and we've got token type.return, token type.while. I'm going to basically just copy this crap over. Parse while. And we're going to create our parse while statement. And I'm going to create it pretty low down here. Current int tokens. So let's see here. Is anyone watching? Oh, we have 4 whole people. Just for a bit of educational stuff here, one of the things that I did differently in this project than the way it was done in most other examples I've seen is I've avoided using global variables. List of donk token. Most parsers and scanners, etc., that I've seen, they sort of move through the source code by incrementing global variables, and I don't do that. Now, the benefit of that is I just find it a lot easier to understand because I don't really understand. I find excessive usage of global variables, which it's almost like friggin' go-to statements or something like that. I find it really annoying to read and understand. Whereas for me, the side effect is every function has to return the new index, so that's how I move through or iterate through the source code. So the side effect is every function has to return an index. But I find it's easier for me to go through with the debugger. It's easier for me to sort of follow along with the code. So I do like that decision, but it has, in a sense, made the code slightly more verbose. So I probably wouldn't want to do this if I was writing it in Java. The pair will be base statement and an integer. Okay, so we've parsed a while. And then we're going to say, okay, how do we do this? So the first thing we need to do, we've parsed the while statement. I need to move the, did I move it over? Yes, I did increment index, so that's good. All right, so we should be looking at the next character, which should be a left parentheses. So what we're going to do is we're going to say if match types tokens index, and then we pass in token type dot left parenthesis. This is where we do our matching. Like I said before, most of what this parser does is we call parse functions, we call match functions, and that's mostly what it does. So if blah, then, so if it matches, we say, what do? We just increment the index. Else, we need to return an error. Error message will be expected left parent at index, but got tokens index dot type. Okay, cool. And then we return index. Okay. Then we do this again. No, we need to now parse the expression. So now we're going to say val parse condition expression equals parse expression. Is that okay? Does that work? Okay, call expression. Call is a subclass of expression, right? Yes. Okay, so that should work. I was just wondering if it needed to be a statement or not, but I think that's fine. So we can say parse expression index tokens. Okay. And we say if parse condition expression is error expression, or error statement, I guess. Yeah. Oh, dot first, that's what it is. So if it's an error, then return pair parse condition. So we basically just pass the error up the call stack, whatever you want to call it. And then yeah, I think that's correct. I might have to increment by 1, but I will burn that bridge when we get to it. Okay, so if it's an error, we break. Otherwise, we again increment. No, otherwise we say parse condition. So one thing we need to do is we need to say val condition expr equals, I think it was a base expression. So we say parse condition expression dot first equals, I messed that up. Condition expression equals parse condition expression. We need to cast it to base expression. Okay, the first cast can never succeed because it's a statement. Base statement. Okay, why is it complaining now? Oh, I see, because I need to say I think I need to actually cast it to expression statement. There. Okay. Cool. And then we also need to say index equals parse condition expression dot second plus 1, I believe. Okay. So we've checked the left parenthesis. It's good. We checked the that there's a expression between the left parenthesis and the right parenthesis. I think that's the singular of parenthesis, but I could be wrong. Now we check for the right paren. Basically do the same thing. And now we need to parse the block statement. So now we'll say, just going to copy that over, parse loop, or let's just say parse block. Okay. And this is that. This wouldn't be this would just be base statement. Val block equals block statement. Sergio says this will be a major work to complete. Yeah, it takes quite a long time to build a compiler. It's one of those, if I can share kind of an interesting thing about for me, what was the hardest part of getting started with building a language is that every little thing you add to the language is potentially going to have a cascading effect of complexity and difficulty. Like at the moment, I'm only implementing while. I might eventually implement for, but even just little things like that, implementing different kinds of loops and those sorts of things. Another thing is the main resource I use to learn compiler and interpreter development, is Crafting Interpreters by Bob Nystrom. And I linked it down in the description box below. Now, in his code and tutorial, his language doesn't have types. It's dynamically typed. I made the decision to make types, so that's going to mean that less and less can I base what I'm doing off of what he's doing. So it's been a fun, difficult challenge. Okay. Let me just figure out what I'm doing here. Type mismatch. Found a block statement. Oh, it shouldn't be parse block. This should be condition expression. No, it shouldn't be condition expression. It should be block. There we go. Okay. All right, so we parse the block expression, and then I think that's basically all we need to do. Yeah, I think that's it. So then what we do, that's the while loop. So we'll say return pair. So we're returning a while statement with condition expression and block. Okay. And then we return index. Now I wouldn't actually increment by 1 here because reasons. Okay, let's rerun the test. All right, got an assertion error. Is this a parse file statement? Yep. Let's see what the error is. Oh, wait a minute. I think that's actually what I want to be looking at. Yep. Okay. Oh, that's where my play button went. Sergio says maybe creates a method that increments the index automatically. You wouldn't have to worry about incrementing or not. It's just tricky because sometimes I should increment it and sometimes I shouldn't. So if you can think of a method which can figure that out, that would work. Okay, so result, we have two errors. Expected an expression but received true. Expected expression but received left brace. Okay, well, let's start here. So expected an expression. I think what that's caused by is I don't think I've set up parse expression to actually handle booleans. So that should be an easy fix. Yeah, I think I just need to go token type dot true or token type dot false, return literal expression. Do I have a separate Boolean expression? Okay, I need to make a high-level decision here. So the thing is, I have tokens to represent true and false here. But those are different from literals. I have a literal expression. Should I add a Boolean expression? Which can either be true or false. Doesn't make sense to do that. What about a value expression? No, I can't do that. I think I need to add a Boolean expression thing here. I think that might be a statement though. Oh, I hate this stuff. Okay, let's just call it a Boolean expression. It's going to be a... Sorry, my neck is itchy. It's going to be I guess it'll be a Boolean. Or should I just keep it as a donk token? I'll keep it as a donk token for now. Okay, and then I need to add that to the visitor. So visit Boolean expression. This thing is growing fast. Okay, let's do that. And then this becomes a Boolean expression. Token current. Okay, that makes sense. Now, why is there just a random index sitting there for no reason? Let's get rid of that. Okay, so if the token's true or false, then we create an expression statement out of a Boolean expression. I'm happy with that. Let's run the code. Okay, it looks like we have an infinite loop. So again, that seems to be generally caused by not incrementing something that should be incremented. So we parsed an expression. Second plus one. Okay, so we're incrementing there. Parse while statement. So it's infinitely looping again, so I need to figure out why it's doing that. And where it's doing that. I think what's happening... Okay, we're calling parse declaration. We get to parse a while statement. We move over. We jump in here. We check the left parenthesis, move over, find the expression, move over, check the right parenthesis, move over, and then we parse the block. That leaves us, I think, at the right. What if we do this? Okay, still infinitely looping. All right, well, I just need to figure out, for starters, where it's infinitely looping. And I think it's probably looping in parse block, because if I recall correctly, that's the only place I actually have a loop. Let's see what's going on. Okay, We got a while statement. Okay, so it looks like I'm just not handling the while statement, I guess. Does that make sense? Yeah, that makes sense. Okay. This is actually a pretty straightforward fix then. At least I think it is. It seems weird though suddenly that I have to add all these different conditionals to the block statement. No, something's wrong here. Okay, so I just suddenly realized this is all completely repetitive code. So what I should actually just do is I should just have else. I shouldn't have deleted that so quickly. Yeah, I thought it was weird that I started having to add all these conditionals here that look identical. So we're just going to say else that. So that'll clean that up a little bit. Now we're getting an error again. And I want to know what that error is. Test one, no, result. Are we getting an error? Okay, we're not getting a list of errors, so it might be that the it might not be like a parser error. It might be actually that the test itself isn't properly formed, or just the structure of what we're returning isn't properly formed. It really could be either of those. So let's look at result. So result is a function statement, which is what I'm looking for. The identifier is whatever stub. Return type is none. We go into the body. The parameters are 0, that's correct. And then we go into the body of the body, and we get a while statement. In the while statement, we have a condition, which is true. And then we have an expression statement. Okay, I think it might be the test itself that isn't properly formed. That's my working assumption here. So there's no parameters, right? Yeah, no parameters, no return statement. It would be a function expression. Is this thing a function expression? Yes. Okay. While statement. Oh, I think I know what it is. It is an improperly formed test. So this actually needs to be a Boolean expression. Okay, and I think it'll pass now. Nope, still not passing. I think that was definitely an error though. I should figure out a way to have it just tell me exactly what is different here. All right, so I need to just compare the expected result with the actual result. Okay, so result. We have a function statement. Function expression, parameters body, parameters body. Okay, and we have a while statement. Let's check the condition. Condition is Boolean expression, true, blah, blah, blah. Condition is Boolean expression, true, true. Okay, so it seems to be an issue in the body itself of the while statement. Yeah, something looks weird here. No, that looks normal. Okay, while block statement, block statement. Within this block statement, we have an expression statement. Whereas in here, we have a literal expression. No, we have an expression statement, and we have a literal expression. Okay, it's really hard to read this thing, but I don't really see, the actual difference between these things isn't actually jumping out at me. Oh, the literal's different. Okay, I think it's just this literal. Does that do it? Okay, so it was just a improperly formed test. It was kind of looking like it was something silly like that. So I'm going to ask, can you tell about the debug red circle mark and how you're debugging? I don't know about debugging in runtime, pausing and continuing. Sure, I'll ramble about that for a bit. So the tool is called a stepper. So basically what it is along the side of the IDE here are of course like the line numbers if you display them. So you can kind of click in this space here to set what's called a break point. And what that does is as the program sort of goes through the execution of the code line by line, if it hits a break point, it will pause the execution of the code at that point, and it will actually tell you what the memory space of the running program is at that specific point. It's actually a useful way to figure out how virtual memory space works on the JVM. So let's do a quick example. So let's say one thing I was doing earlier is when I was parsing a block statement, which could have a variable number of statements in it, therefore I needed to have some kind of loop, I wanted to see what was happening. So what I did is I looked at kind of the first function that gets called, the first line that gets executed after the loop declaration itself, and I stuck a breakpoint in there. Now I'm going to hit the debugger button, not the run button. And what it's done, as you can see here, is it's paused the execution of the program at that specific point in time. And then in this tab here, it gives you the memory space for essentially anything that's sort of running at that particular point. So what I can do, the things I would want to pay attention to is, for example, the index. Oops, I don't know what it thought I clicked on, but that's not what I wanted. Sorry, let me just restart it. Okay. So I'd be concerned about what the index is doing, because obviously the index represents sort of where in the source code that we are looking. And then I'd also be concerned about like what is the current token that we're looking at, kind of thing. What you can do from there, and you kind of just need to play around with it for a while. You've got these buttons up here. So you've got step over, which will kind of move just to the next executed line of code here. So if I hit it, it'll jump to parse result. You've got this play button, and this will jump to the next breakpoint. So let's say I want to just kind of go through here quickly. I can hit these breakpoints if I don't care about what's going on in this loop anymore. And then it takes me right to the next set of breakpoints. So there's also like a step into, and this will actually go into the method or the function that's being called. Sometimes that can be useful, other times it will just be really obnoxious. So mainly what you want to do is you want to just start practicing with it and play around with it, and eventually you'll figure it out. And that's basically it. In my courses, Working Class Java and in the Kotlin course, I actually use the debugger to teach different things. Like I use the debugger to solve the problem of whether Java and Kotlin are passed by value or passed by reference, for example. And certain questions that people get really confused on, you can answer them really easily using the debugger, because it will tell you, here is exactly what's going on in the virtual memory space. So it's a really useful tool to learn how to use. Hey, what's up, Cybershark? Okay, so we've got while statements parsing. I'm going to rerun all my tests, and then I'm probably going to call it a day. We've been going for about 2 hours, I think. Yeah, two and a quarter. Let me just rerun the tests. If anyone has any other questions or comments, then let me know. I don't remember, like, Cybershark asks, is there a way to go back after an accidental step over? I think there is. Like, I know how to do that with with an accidental step into. I don't remember if you can like click on one of these things, or I don't know. Short answer, I don't know. Okay, let's run my tests. Yeah, no worries, Swamanath. Swagro says, now that you mentioned your courses, are the ones you have on your YouTube channel all of them? I've seen a bit of your fundamentals posted on Free Code Camp, and I got amazed by your superb way of explaining. Thank you, that's a very nice compliment. Yes, all of my courses are available on my channel for free. The best thing to do is go to the playlists section, and you'll see playlists which have the various courses on there. I don't think my, yeah, that's the best way to do it. Okay, so our parser declaration tests are working. Now let's do the parser statement tests. And those are all working. Cool, lots of green lights. We implemented return statements and while statements. and also Boolean expressions. So this has been Ryan rambling away here and doing some live coding on my compiler. Hopefully that was enjoyable for you. I think at the start of the previous live stream, I explained a lot more about how the other stuff like the scanner and that works, and yeah, that's basically it. I'll probably be live again around the same time. I started 2 hours ago, so 2 hours from now, and I'll be doing more work on the compiler. I'm basically trying to do some live coding pretty much every day, and then on Sunday I will be doing an actual live Q&A where instead of just live coding, I will be answering questions the whole time. So thank you so much for watching, and I'll probably see you